All right, listen up. This is a Code Ninja security advisory. We've got an active threat on the wire, so I need your full attention.
The identifier you need to be tracking is CVE-476-3202. This is the official tag for a brand new denial of service flaw, and trust me, it requires your immediate action to protect your analysis infrastructure. Let's get right into the intel.
Okay, let's break down the snapshot. The software we're talking about is Wireshark. Yeah, the tool that's on practically every analyst's machine. The specific versions you need to worry about are 4.6.0 all the way through 4.6.3. The vulnerability type? It's a denial of service, which means a bad actor can crash your application and they can do it remotely.
So why are we putting this out there? Our objective is twofold. First, to give you the immediate mitigation protocols, the steps to protect yourself right now. And second, this puts pressure on the vendor to get a patch out the door fast. This is coordinated vulnerability disclosure in action.
Now, before we get into the nitty-gritty, we need to do a quick comms check. Any coordinated response relies on secure communication lines. It is absolutely critical that you can get future intel like this the second it drops.
All right, here's your security protocol. 3 steps. 1. Subscribe to this channel. Think of it as establishing a secure, real-time intelligence link. 2. Hit that like button. That's your ACK, your acknowledgement receipt, so we know this transmission landed. And 3, this is important, drop a comment with your status. Are you patched or vulnerable? This gives us a boots-on-the-ground census to gauge the real blast radius of this thing.
Comms check complete. Good. We're now moving into the threat protocol phase. It's time to dissect this vulnerability and get you the patch procedure.
So, let's get technical. The weakness is officially classified as CWE-476, a null pointer dereference. What does that actually mean? Well, in simple terms, the application, Wireshark in this case, is tricked into looking for data at a memory address that's completely empty. It's a void, a null address. And when a program tries to read from a place that doesn't exist, well, it just crashes. Hard. So here's how the attack actually plays out, step by step. It all starts with you, the analyst, just doing your job, capturing live traffic or opening a PCAP file. Now, if that traffic contains a specially crafted, malformed packet using the NTS-KE protocol, the Wireshark dissector, the part that's supposed to make sense of the packet, fails to check if a memory pointer is valid. The result? An immediate, unrecoverable crash of your entire Wireshark session. Game over.
Let's be crystal clear about the blast radius here. This isn't about stealing your data. No, this is much more insidious. It's about crippling your operations. An attacker can use this to kill your analysis right in the middle of a critical incident response. Think about that. They can literally blind your security team at the exact moment you need to see what's happening. This is a direct assault on the integrity of your forensic process.
Now, you might see some conflicting numbers on just how bad this is, and this slide breaks down why. You've got the National Vulnerability Database scoring it at a 7.5. That's high severity. They're looking at it as a network-based attack, where a bad actor can just inject a packet into your live capture. No user interaction needed. But then you have Red Hat rating it a 5.5, moderate. Their threat model assumes a local attack, where you have to be tricked into opening a malicious file. For our purposes, we always plan for the worst-case scenario, so we're aligning with the high-severity rating.
Okay, this is the most important part, your mitigation protocol. Your primary directive is simple. Upgrade. Get every instance of Wireshark you have to version 4.6.4 or later. That is the permanent fix. End of story. Now, if for some reason you can't patch immediately, there is a temporary workaround. You need to go into Wireshark settings and manually disable the NTS-KE protocol dissector. And on top of that, you need to be following these safe handling protocols as a rule. If you're using T-Shark, the command line version, you can use the bash D flag to disable the bad dissector on the fly. And honestly, this should be standard procedure for everyone. If you get a PCAP from an untrusted source, always analyze it inside an isolated virtual machine, a sandbox. Contain the threat.
All right, let's wrap up with our final segment, the disclosure code. It's important you understand exactly why we're out here giving you all these technical details.
And I want you to really understand this. We are not doing this to arm attackers. Believe me, they already know these tricks. We are here to arm you, the defenders. We release the mechanics of these exploits to force a rapid fix and to make sure your tools maintain their integrity and availability. Our code, our ethical directive, is to protect the community.
And that concludes this security advisory for CVE 2026-3202. Now, go execute the mitigation protocol
verify your comms link, and stay secure.